Hi friends, welcome back. Today we are going to solve another important Leetcode coding interview problem 1926 nearest exit from entrance in maze. So this problem was also asked by big companies in their interviews. So if you are a fresher, junior level developer, you are planning to take any interview rounds, make sure you watch this video until the end. So you will completely understand the logic, how we can solve this problem, and also you will completely understand how we can write and implement our Java solution code to solve this coding problem. Before we start looking into the details of this problem, along with few examples that I created, I would like to quickly mention that this channel is to help people in their coding and Java interviews. On this channel, you will find more than 500 different varieties of coding problems solved and explained using whiteboarding sessions, examples, and Java code for your easier understanding. Many of those problems are previously asked questions by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft, LinkedIn, and many other big tech companies. Among those solved coding problems, you will see all important coding questions varieties are covered in them. That includes problems related to graphs, matrices, binary search trees, different algorithmic problems, including depth first search, breadth first search, cadence algorithm, binary search algorithm, Prim's algorithm, Kruskal's algorithm, as well as many other important algorithms. There are also problems related to strings, linked list, optimization problems, dynamic programming questions, as well as lots of logical coding interview problems are available on this channel, explained with examples so that you can easily understand those problems. If you want to learn more data structures and algorithms, this is the best place. We have lots of important data structures and algorithmic interview problems explained with examples on this channel that includes different varieties of problems related to stacks, queues, priority queues, hash table, hash map, tree set, hash set, linked hash map, linked hash set, as well as many more important data structures related coding interview problems. So if you are preparing for any coding rounds of interviews or Java rounds of interviews, or you simply want to learn different concepts of computer science, programming, data structures, algorithms, problem solving, logic building, and Java coding, then this channel can definitely help you in doing so. So please subscribe to this channel now. Also, when we come across any important coding problems or interview related coding challenges, we create videos to help others also learn how to solve those problems and to help others also learn how to implement their solutions. So make sure you click on the bell notification icon right away so you won't miss any important interview related helpful videos for you on this channel. So let's start with this Leetcode problem 1926 nearest exit from the entrance in maze. So as you can see, this is quite likable coding interview problem. It's on Leetcode medium complexity problem. So let's go through the problem statement first. Then we'll go through some examples. You are given an m by n matrix maze, 0 indexed, with empty cells represented as dot and walls represented as plus sign. You are also given the entrance of the maze, where entrance is equal to entrance row and entrance column, denotes the row and column of the cell you are initially standing at. In one step, you can move one cell up, down, left, or right. You cannot step into a cell which is a wall, right? And you cannot step outside the maze. Your goal is to find the nearest exit from the entrance. An exit is defined as an empty cell that is at the border of the maze. Right, this is important. The exit is defined as the empty cell which is at the border of the maze, and the entrance does not count as an exit. Right, okay. Return the number of steps in the shortest path from the entrance to the nearest exit, or -1 if no such path exists. So we'll go through these examples. So constraint says that the maze dot length is m, maze I dot length is n. So number of rows basically is m, number of columns is n. The rows and columns can be maximum 100. So 100 by 100 is the maximum size of the matrix, and the matrix will contain dot and plus signs, right? And every cell has a length 2 because entrance dot length is 2 basically, right? And then entrance row is between 0 to m, entrance column is between 0 to n. Entrance will always be empty cell. So let's take a look at the examples they have given us. So they have shown us a graphical representation of this matrix. So these are the walls, right, which are shown in this red color, and this is where you are standing basically initially. So the exit is any cell which is at the border, which is like next to the border. So this is the exit cell here, right, and this is the exit cell. So which is the closest exit cell? This is the closest exit cell here, right? So how much is the distance? 1. So this is what we have to find out. 1 is the distance. One step you can reach here, right? So in this case, the nearest exit is this one, because you are actually standing into an exit, but this is not counted as an exit. You have to find out another exit, right? So another exit is 1 and 2 steps here, right? So that's why the answer is 2. Here there is no exit you can go, right? You are standing into exit, but this cannot be considered as an exit. You have to find another exit. So now it is already 2 cells and got blocked by the wall. So there is no other exit here, so you will return -1. So this is what the problem statement says. So the wall is represented as a plus sign here, and these empty cells are represented by dot. So I created another bigger example here, so we can discuss it more here, right? So plus is the wall basically, right? And this dot size, dot is basically a empty cell. And what are the exit is this cell is, for example, this is a exit, right? Because it is on the edge, right? And it is dot. This is another exit on the edge, right? And dot. This is another exit on the edge and dot. This is another exit on the edge and dot, right? So these are the 4 exits. So they have given us where you are standing initially. So you are standing at a cell which is 3, 4. So this is 0, 1, 2, 3, right? So third row and fourth column. So 0, 1, 2, 3, 4. So this is where you are right now basically, right? And you want to find out the nearest exit for you from this cell. So which can be nearest exit for you? So either you can go 1, 2, 3, 4. So this is 4 and this is also 4, right? 1, 2, 3, 4. So any exit is you can take. This is the nearest exit. This exit is not nearest because it will take you 1, 2, 3, 4, 5 and 6. 6 steps it will take you. So this is 4 steps, this is 4 steps, right? And this one you cannot reach because it got blocked by the walls, right? So you cannot reach it. It's got blocked by the walls. So we have to find out the nearest exit is, in this case, is 4. So this is what the output is, 4, right? So the problem statement is clear, right? The exit is the empty cell which is on the edge, right? On the edge, as you can see, this is on the edge basically, right? And then we have to find out basically a shortest path. In another terms, we want to find out shortest path to the maze exit, right? So these kind of problems are typically solved by using BFS or DFS approach. So in this current video, we are going to discuss the DFS approach here, right? Which stands for depth first search or depth first traversal, right? So how it is different than BFS? In DFS, you will take one direction and you will go all the way in depth basically, right? You will go all the way in depth in that direction. For example, you take this direction, you go all the way in depth. So you will go here, then you will take this direction, you go here, from here you will go here, right? So you have explored all possible paths in this direction. Then you will start exploring other direction like this, right? So this is the way DFS works, right? So this is different than BFS. BFS is different because BFS works on level by level traversal. Now this is different. This is a DFS that we are talking about right now, which is depth first search or depth first traversal. So we'll be using recursion for this. So what we will have to do in this case, so we will have to what they have said is we can go in 4 possible directions. So what it means is, I'll just quickly explain it to the freshers who doesn't know this, so it will be clear for them. So let's say this is our matrix, let's say, right? These are a couple of cells. So I'll just draw it a little big because I want to write something there. So let's say these are the cells, right, of the matrix. Okay, and you are right now you are standing into I, J cell. Okay, now you are allowed to go in 4 directions. So 4 directions means you can go up, down, left and right, right? So let's say you want to go up, then what you will do, you will do I minus 1j basically here, right? So you are going up. If you are going down, it will be I plus 1j, where I is row, right? When you want to go right, it will be ij plus 1, right? Ij plus 1. And when you want to go left, it will be ij minus 1, right? So these are the four possible cells that you can go from this cell, right? Because you are allowed to go in up, down, right and left directions, right? So for every cell in this DFS, we will try to go in all four possible directions if these are the valid cells. So what is the valid cell means? Valid cell is a cell if this new cell should be inside the boundary of the matrix, right? If it is outside of the boundary of the matrix, it cannot be a valid cell, right? That is one thing. And other thing is it should not be a wall, right? It should not be a wall. If it is blocked cell like wall, then we cannot go there, right? So we have to find we have to take care of those things. Let's say it is a valid cell, then we will start exploring the path in that direction. For example, let's say we are going on the right side, so we'll first go here, right? Then we will, from this side you can go two places, you can go to here and you can go to here, right? You cannot go back to here because you already visited this cell, right? So we'll keep track of the cells we have visited. So you will, let's say you are going on this direction, so you will go here and then here and then here, right? And when you reach the exit cell, it will return you 1, basically it will return you 1 because it took you one step to reach here, right? Now this one will return this cell 2 because actually it took 2 steps from this point to reach here, right? From this point it took you 2 steps, 1 2 to reach to the exit. This cell will return 3 to this cell, right? 3 to this cell it will return, and this cell will return 4 to this cell. It means that actually it took you 4 steps from this starting point to the ending point. Ending point is a exit, right, in this case. Now we will keep track of what is the steps required from this point, right? From this point. So at this point we have seen that we require, for this, from this point we require 3 steps, right? So now it is possible that if you go in other directions, it may require you less steps than 3, right? Right now it is not requiring less steps, but it is possible that it may require you less steps. So if it is requiring less steps, whatever is the minimum we will take, right? Because we want to find out shortest path. So now once you have traversed through this direction, you want to now check the other direction. So you will go here, then here and then here. Again same thing will happen. It will return you 1 from here, it will return you 2 from here, it will give you 3 from here, right? So it means that from here to here it will take you 3 steps basically. To reach from here to here it will take you 3 steps, correct? And then one more steps will be taken because of this, right? So it will take you 4 steps. So whatever is the minimum we will give it back to this cell. Whatever is the minimum we will give it back, correct? Because our purpose is to find out minimum or nearest exit, right? Shortest path. That's why we will give it minimum to back to this cell. So this is a DFS approach. When you explore one path from this cell, you will have to use backtracking basically, right? You will also have to use backtracking because you still want to explore other paths which can start from that cell like this, right? So we'll use a backtracking for that. Now once these paths are explored, you still have some other paths to explore. So that's how DFS works, right? So now you will explore these paths, right? This is another path that you can explore, right? Again it will return you 1 from here, 2 from here, 3 from here, 4 from here, 5 from here and 6 from here. So it means that it takes you 6 steps from here to here, right? So whenever you will get these results basically, so you will get results. So it took you 4 and 6. So whatever is the minimum you will take from this basically, right? Because we want to find out shortest path. So that's why we will take the minimum from these results. So this is how the DFS solution will work. So I just wanted to explain you first and then we'll go to the code. So it will be clear and easy for you to understand how the code works. So now we'll go to the code. So it will be more clear for you. We have created 2 arrays here. One is for row directions, another is for column directions. This is useful to go in 4 possible directions. I shown you 4 possible directions, right? So that's the reason we have created this row direction and column directions array. We'll use it. This is our main method that we are implementing. Nearest exit, it's going to return integer. We get the maze, which is character array. We get the entrance, which is our initial location, right? Now we'll create couple of variables. M is the number of rows, n is the number of columns in the given maze or matrix. Maze is nothing but a 2D matrix, right? And then min is integer dot max value, and this is for memoization, right? Memoization is used because we want to optimize this code, right? We want to optimize this code, so that's why we will use memoization here, right? So what this memoization does is, if you already knows the result for that step, then there is no point to recalculate it again, right? So that's why we will use memoization to store our result basically, right? So this is a 2D array of same size as the grid. Now here we will mark the start as a visited, right? So visited means we will change that dot to plus sign, right? We will not use any other array. We'll just use the same array. We'll just change it to plus sign, because plus is a blocked cell, right, which is a wall, right? So we'll just change it to wall cell, right? Entrance 0, entrance 1 is the where our starting point is, because we will start from that location, right? Now we are going to go in all the 4 directions, and we will start doing the DFS in all the 4 directions, right? So steps to reach exit is the method we will implement. It will give us how many steps it has taken to reach to the exit from this in this direction basically, right? So we'll get one result back from this method. We'll get a result back which will tell us the shortest path to reach into that direction to a exit, right? So for example, so I'll remove these colors. Okay, so it tells us shortest path. If you go in this right directions, what is the shortest path to go into this direction? 4, right? So this is what it will return us basically, this result. And if this result is not equal to integer dot max value, then we will update the result with minimum. We have a variable minimum which will keep track of the minimum number of steps to reach to the exit here. Mat dot mean between mean and results will take keeping track of the minimum number of steps, right? And at the end we will just check if this integer this minimum is not equal to integer dot max value. It means that we actually find out some smallest steps, so we'll return minimum. Otherwise we never find out any exit that we can reach, so we will return -1. So now we will look into the details of this, how the DFS works, right, using this steps to reach exit function or method, right? So this is a DFS method. So what it takes as an input is, it takes a maze which is 2D matrix, it takes the entrance where we are right now, right, and it takes memoization array, and it takes m by n size, right? Okay, so now we will first read where our current location is, right? The current location is coming through this enter array, right? So row and column, we get the current location for this DFS function, and we will check if this row and column, if it is outside the boundary of the matrix, we will just return integer dot max value, because integer dot max value, you can imagine it as an infinity here, right? So it means that you cannot reach to that cell basically, right? It is outside basically. So we are checking if it is, this cell should be inside the matrix, right? So if it is less than 0, row is less than 0 or greater than equal to m, means it's outside of the boundary of the matrix, or column is less than 0 and column is greater than or equal to n, it means that it is outside of the matrix, right? So we'll directly return integer dot max value, correct, because that is not a valid cell basically. Okay, the next thing is, we want to check if this cell is not a plus sign. It should not be a blocked cell, right, or it should not be already visited cell, right? If it is a already visited cell or a blocked cell by wall, then we'll again return the integer dot max value. It means that it is kind of unreachable basically, right, you can say. Okay, now we found out a cell, right? We found out a cell, so which is actually a exit cell. Now we find out a exit cell. What, this is the exit cell, right? This is the exit cell. So whenever we find out this exit cell, it will give 1 back to this cell basically. That's how we calculate, right? Once this cell gets 1, it will return 1 more into that, so it will give 2 back here. Once it gets 2, it will return 1 more, so it will get 3 here. From here it will add 1 into this 3, so you will get 4 here basically, right? So this is how the DFS works. So as you can see, we are returning 1. We are counting it as a one step basically, right? So we'll return 1 here. Okay, and then we will check if we already doesn't have the result for that row and column, right? So because we always store the result into memoization array, right? Memoization of row comma column, it is null, means we don't have the result, so we have to calculate the result basically now. So maze of row comma column is plus, so we are marking it as a visited cell, so we should not revisit it again, right? After that, minimum is integer dot max value, and we are now going to go in 4 possible directions again, right? These are the 4 possible directions that I shown you, correct? And we will recursively call these steps to reach exit method. Now this is important, we are recursively calling. This is how DFS works, right? This is how DFS works. Steps to reach exit is the method. We are recursively calling it in 4 directions, right? Again, we will pass maze. We will pass new coordinates of the cell. This is very important. This is the very important. We are passing new coordinate. How we are calculating it? The original row plus row direction I, correct? Column plus column direction I. So we have calculated new cell, for example this cell, then this cell, then this cell, and then this cell. So 4 directions, right? And we are going in 4 possible directions. We will get the result back from this function, and we will again compare it with integer dot max value. And then if it is not integer dot max value, it means that we actually found out some result, right? So we have to keep track of the minimum between minimum and result, right? And here, if minimum is not equal to integer dot max value, we will increment the minimum, right? Because we have to still count our current cell basically. Current cell, we have to count it once, right? So what I mean to say is, when let's say when we start DFS from this point, if it is giving you 3 from here, then you have to still count one step for this, right? This one step you have to count. So actually it took you 4 steps, right? So that's what we are doing here. Okay, min is equal to min plus plus means, right? After that, we will put this result into our memoization array. So we don't want to recalculate it again, right? So it is an optimization mechanism basically. So memoization of row comma column is equal to this minimum that we got it here, right? And then maze of row comma column is equal to dot. What we are doing here, we are actually backtracking. So we are changing it so that we can explore other directions, right? So we have explored this direction, so that is fine. But from this point, we still have other directions which are possible, right? Like this. So we want to still explore this direction, correct? So it means that whatever we changed plus sign, we have to change it back to dot, so that we can check out the other possible paths, right? So this is for backtracking, so that we can explore remaining paths from that point, right? And then here we will return the memo of row comma column, which is going to give you the actual result back. The actual result from this starting point, right? You will get it back here, right? And then you will compare it with your minimum here, right? So minimum here is different. Okay, this is the minimum here, right? So so this minimum and this minimum is different. Okay, this is another minimum in this another DFS method, right? So that's how you will keep track of the minimum number of steps that is required to reach to the nearest exit from that starting point. So I hope it is clear to you how the DFS works here. So we have just implemented a recursive function here that will keep going in 4 possible directions, and it will keep checking the minimum distance, basically a minimum number of steps to reach to the exit cell. And we always store the result that we get into this memoization, so that if it is already available, then we don't have to do this again, right? Because we always check if this result is available first here, right? If it is not available, then only we have to do it. If it is available, no need to do it, right? So that's what it means. So now we'll go to the some examples, make sure this code works correctly. So these are the some test cases. So this is the first example. Let's take a look. So we are expecting 1 as the answer, and we are getting 1 as the answer, which is correct answer. This is the same test case 1, which is this one. The test case 2, we are expecting 2 as the answer, so let's go here. So this is the test case 2, which is 2 is the correct answer, and for test case 3 we are expecting -1 as the answer. Test case 3 we are getting -1, which is correct answer, and the test case 4 is this one, the bigger one, right? So we are expecting 4 as the answer here. So this is the bigger one that I created, so you are getting 4, which is correct answer. So this is how you can solve this interesting coding problem. It's on Leetcode 1926, nearest exit from entrance in maze. So we have used DFS approach to solve this problem, and I hope you understood this code clearly. How the DFS, we have used these 4 directions, row and column array, and we have used DFS as well as memoization to solve this coding problem. Memoization is used as an optimization mechanism, right? So that it won't time out, right? Because if you don't do memoization, it will take you more time. So this is an optimization mechanism. You are just storing the result here. Here you are storing the result, whatever you are getting. So you don't have to recalculate that result again and again, right? Because now you already know what is the minimum path from that point, right? So you don't have to again calculate that. If you are new to this channel, we have created a very important coding interview related playlist for you on this channel. It is called as Leetcode and Leetcode Solutions. We have compiled more than 250 most frequently asked very important coding interview problems for you under one playlist there. Those are the coding problems that got asked by Google, Facebook, Amazon, Apple, Microsoft, Yahoo, Uber, Lyft, LinkedIn, and many other big tech companies in their interviews many times. So those are very important coding interview problems there. Make sure you go through all those problems, understand the logic behind the solutions, and also understand how the Java solutions code is working for those problems, right? Everything is explained for you in those videos along with examples so that you can easily understand those problems. If you go through those videos, you are going to learn a lot about data structures, algorithms, problem solving, logic building, as well as how to approach and solve medium to difficult level coding interview problems and how to implement their solutions in Java. So it's going to help you learn lots of new techniques of problem solving that you can apply in your interviews. You are also going to learn a lot of Java coding there. You will come to know about what are the frequently used Java classes and APIs that we often need during the implementation of different concepts and different solutions. So it's going to help you learn lots of new things there, and it's definitely going to help you in your interview. So make sure you check out those important videos from this channel. If you are a fresher, you are a junior level developer, we have created 3 other major playlists to help you for your practicing purpose, where you can practice more coding problems for your learning purpose as well as for your interviewing practices. The 3 major playlists we have created for you here. The names of those playlists are Code Forces, Code Chef, AdCoder. Code Forces, Code Chef, AdCoder. All in all, more than 500 problems are here to help you in your interview preparation and learning process. If you are a Java J2 developer, you are a junior level developer, you are a fresher trying for interviews, then on this channel we have created lots of helpful videos to help you in your interview preparation purpose. For example, frequently asked Java telephonic interview questions and how to answer them, Java design patterns, Java architecture, SQL programming questions to the freshers, where they will give you database tables. They will ask you to write SQL queries where you may have to use different database concepts like inner join, outer join, left outer join, right outer join, aggregate functions, as well as group by and having clauses. Everything is explained for you with examples and the tables of databases, so you will get more idea about those questions. You can also write those kind of SQL queries, so you can easily understand how to write SQL queries there. Check out those videos. There are also videos that discusses recently asked Unix questions to the freshers. For example, Unix commands, Unix utilities, shell scripting questions, all are here to help you in your interview rounds. If you like this video, if you find this video helpful, and if you like this solution where we have used DFS and memoization to find out the shortest distance to the nearest exit, then please give it a thumbs up to the video, give it a like to the video, subscribe to this channel. Subscription is very important because that is the way the videos can reach to many more people, so other people will also be able to watch these videos. They will also be able to learn more ways of problem solving and Java coding from these videos. So if you like this video, then do subscribe to this channel, share this video with all your friends, give it a like to the video. Your friends will also be able to watch these videos. They will also be able to learn Java coding. They will also learn more problem solving along with data structures and algorithms from this channel. If these videos are helping your learning process, you are learning new things on this channel, you are learning more problem solving here, you are learning more coding here, you are learning more data structures and algorithms here, then don't forget to mention that into the comments. Your comments are very important for us. That increases our motivation to create more quality content. So if this content is useful and helpful for you, then do mention into the comments. I'm going to add this Java solution code in my GitHub project. I'll give you the link of this code so you can check it out. There are lots of other important Java solutions code and algorithms available there. So if you want to learn more coding, you can go through them. If you like the Java solutions in the GitHub project, consider giving it a star on the GitHub project. That would be great. Keep learning, keep coding, keep solving more varieties of coding problems, and most importantly, keep your learning process going on continuously. And thanks for watching this video.